Hello, what we're going to do in this video is go through proportions and triangles. So we're going to start with kind of a review of looking at this segment that is parallel, DE being parallel to BC, and draw up a proportion and solve for a given length, and talk about what's called the angle bisector proportional side theorem, which says, hey, if I cut this angle A in half, what sides are proportional, or like what relationships would be driven by that. And then we're going to go through a couple examples of that, as well as some algebraic examples, so they're a little bit more tricky. And then we'll finish talking about what's called the proportional segment theorem, which is really built from the other one, and then go through one example. And that is it. Pretty short and sweet. So first problem, we're going to draw up a proportion here, taking a look at the fact that the side AD over AE, so x minus 2 over 3, is equal to, if I take this part, which is x plus 3, over the corresponding part, which is the 5. So this is one way of going about this, and I've tried this another way as well. So the other setup, if you were to focus on the small triangle, having the x minus 2 over 3, and then focusing on the large triangle, which has these two sides, if you were to look at this entire side over this entire side, so this entire side, if you were to add everything up, you would have 2 of the x's, and then a positive 3 minus a 2, which is a positive 1. And then this entire side would be 5 plus 3, which is 8. And these cross products are actually going to be equal to each other. So what we're going to end up with, and I'll solve the easier one, is if I do 5 times x minus 2 is equal to 3 times x plus 3. And I'm going to distribute my 5, and I'm going to distribute the 3, and get 5x minus 10 is equal to 3x plus 9. Subtract 3x on both sides, and that's going to end up giving me 2x minus 10 is equal to 9. Do the work up here, so that's 2x is equal to 9 plus the 10, which is 19. And then when I divide both sides by 2, I end up with an x value of 9.5. So in this problem, I want to find the length of segment AB. So what I'm going to do is substitute x into both of these values here. Or, again, we can write an expression for the entire segment length. So I'm actually going to do that. So this entire segment here would have x plus 3 plus x minus 2, which is 2x plus 1. Now, if I want to find what AB is, all that I have to do is substitute my x in for that one time. So 2 times 9.5 plus 1. We know that 2 times the 9.5 is 19. And then 19 plus 1 gives me a length of 20. So now we're going to go on to this theorem. So the angle bisector proportional side theorem, which says that we are going to cut angle A into 2 equal pieces. So if I cut A into 2 equal pieces, we would call the side AD an angle bisector. So it divides this angle into 2 equal pieces, and it creates this proportion where AB, which I'm just going to call x, over AC, which I'm going to call y, so I have an x over y, is equal to BD, which I'm just going to call a w, and DC, or CD, which is z. So I'm going to write it like this. And then this would just give us a nice cross product as well. So recognizing that I can take this x over y equal to w over z would give me a cross product of xz equals wy. So I'm going to kind of pause for a sec and do one other proportion that actually is true from that. If I compare the x over the w, so if I took x over w, that would be proportional to if I took y over z. And then notice if I take a cross product of this, I still get xz is equal to yw or wy, and you get the same thing. So there are a couple ways to do these problems. So let's go through some examples. So in this first one, we're given that CD, the line segment, bisects angle C. So this angle is cut in half, and we want to determine in this case what dB is. So I'm going to throw a little x there, and then again, I'll give you 2 ways to go through this proportion. So the first one that I can write that comes from the theorem says if I take 30 over 24, that is equal to x over 8. And that is one way of going about it. Another way that we could go about it is to take 30 over the corresponding length of x, so 30 over the x, would be equal to 24 over 8. And notice that in both of these examples, what's being multiplied is the 30 and the 8 and the 24 and the x. So you end up with 24x being equal to 30 times 8. So 24x is equal to 30 times 8, which is 240. And then when I divide both sides by 24, I get an x value of 10, which is what segment DB represents. So you'd get that same answer even if I multiplied on this side. I would still have 24x is equal to 240, and you'd obtain the same x value. In this next one, we're given the same thing. So CD is bisecting angle C, and we want to figure out what segment AC is. So I'm going to label that as the letter Y. Same thing here. I can take 22 over the Y. So if I look at those corresponding parts, 22 over Y, the order matters. If I started with 22, I need to go back to this 11 over the segment length of 9, and I can cross multiply and end up with 11Y is equal to 22 times 9. So what I'm going to end up with then is 11y is equal to 198, and then when I divide both sides by 11, I get a y value of 18. And that's what the side length AC is. And what you can also see is that relationship. If I look at DB to BC, so from 11 to 22, you're really doubling. So I'm multiplying by 2 to go from that length to the longer one. And then that same thing occurs here. If I take 9 and I double, and I end up with 18. So the fact that I have this doubling means that those relationships are proportional. So here's one more example. This one's a little bit more complex. So in this example, I have that angle A is bisected by the length AD, and we're given a 7, I'm given a 14, and we're saying that this value, which I'm calling x, which is AC, if I take that value and I add this y value for AB, I get 36. So I'm going to make a couple equations out of this. The first one is just to rewrite that. So I know that x plus y is equal to 36. And then I'm going to make a proportion out of this. So again, I can take x over y is equal to 7 over 14. So x over y equals 7 over 14. And then if I cross multiply this, I get 14x equals 7y. And then what I can actually do is solve by isolating the y. So I know that y is equal to 14x over 7, which is really 2x. So whatever y is double whatever x is. And you can also see that relationship because the 14 is double the 7, so the y is going to be double the x. So all that I'm going to do is take this little fun fact that y is equal to 2x, and I'm going to substitute that in for y. So I know that I have x plus 2 of those x's is equal to 36. That gives me 3x equals 36. And then x equals 36 divided by 3, which is 12. And that's what our length of AC was. So that was 12. And we know that my y value was equal to 2 times that x value. So 2 times 12 gives me a y value of 24. So what I'm going to do is just kind of take this a step further then, go back at the very end, and I'm going to substitute 12 in here and 24 over here, and I'm just going to rewrite this proportion one more time and verify that it works. So if I take 12 over 7, I should have that equal to 24 over 14. And if you cross multiply this, I can do 7 times 24, which gives me a value of 168. And if you take 12 times 14, you also end up with 168. So that means that our answers are right. And at the very end, I'm going to just double check that they satisfy that if we add our answers together, it adds up to 36. And 12 and 24 do add up to 36. So here's another one as well. BD in this case bisects angle B. So angle B is the one that's cut in half here. And we want to determine this entire length, AC. So what I'm first going to need to do is draw up a proportion and identify what this length is here. So I'm going to call that length x. And I'm going to write a proportion that says 14 over 16 is equal to 6 over x. And again, you could have also done 14 over 6 is equal to 16 over x. And you'd still end up with 14x is equal to 16 times 6. And that's 14x is equal to 96. So when I divide both sides by 14, I'm going to end up with a pretty ugly answer here, so I'm going to round to the nearest hundredth, and I get a value of 6.86. So again, writing up that proportion, if I would have done it the other way, I still get 14 over 6 is equal to 16 over x. And in this case, you'd still end up with 14x equals 16 times 6, which our 16 times 6 gave us 96. Dividing both sides by 14, we end up with this ugly decimal. So again, I just rounded it off as 6.86. And that value is going to be the one that helps us determine what AC is at the very end. And all that I'm going to do is take 6 plus 6.86, and that gives me AC, which is 12.86. So now we're going to go on to this last theorem called the proportional segments theorem, which says if three parallel lines, which are L1, L2, and L3, if they intersect two transversals, which are these two diagonal lines coming across, then they divide the transversals proportionately. So notice the proportion which says I could do AB over BC and set that equal to DE over EF. And that would also work out, again, if I kind of illustrate this the way I did before, if I write this here, I'll start like this. I'll just W, X, Y, and Z. And I'll write out a couple proportions. So the way that the first one is written here says if I take AB, which is my W, over BC, which is my X, I can set that equal to Y over Z. Notice that my cross product would be WZ times XY. I can also write the proportion by taking these corresponding parts, which is W over Y, and setting that equal to X over Z. And once again, notice if I take my cross multiple of this, I end up with WZ is equal to XY. So you get the same thing both ways. So whichever one you prefer, you can go with that. And what we're going to do is just work out one last example of this, solve for X, and then sub that value back in to determine the length of segment KJ. So either one of these proportions will work. I'll write out both. We can do 15 over 3x plus 2 is equal to 18 over 5x minus 6. Or we could do 15 over 18 is equal to 3x plus 2 over 5x minus 6. Again, both of those proportions will work because when I end up doing my cross multiple, the 15 is going to multiply by the 5x minus 6. And I know that the 18 is going to multiply by the 3x plus 2. So it doesn't matter which one of these we use, we get the same thing either way. 15 times the 5 gives me 75x. 15 times the negative 6 is negative 90. On this side, I have 18 times 3x, which is 54x, and then 18 times the 2, which is 36. So what I'm going to do is subtract 54x on both sides, and that's going to end up with 74 minus the 54x gives me 21x minus 90 is equal to 36. And then what I'm going to do is bring the 90 to the other side by adding. So I end up with 21x is equal to 90 plus 36, which is 126. And then if I divide both sides by 21 at the very end, I get an x value of 6. So we don't want to stop there. That is the x value, but that's not our answer to the problem. The problem wants to know the length of that segment. So what I'm going to do is just create an expression very similar to the way we did that first problem. I'm going to create an expression that represents this entire length. So I know that if I do 3x plus 2 and I add my 5x minus 6, I'll get that length. So that's 8x minus 4 is the entire length of that segment. And all that I have to do is substitute an x value of 6 in for x. So I get 48 minus 4. And our answer then for KJ is 44. So quick recap going over this entire video. Starting off, we did some proportions just within a triangle, looking at a segment that was parallel to a base. And then we went through this angle bisector proportional side theorem, went through a couple examples of that and various ways to solve those problems. And then we went into the proportional segments problem, followed by one example of that.